SwayamPrabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on groundwater hydrology and management. This is a very unique course looking at specifically groundwater hydrology and how you manage it across. We'll be looking at both rural and urban regions in this part, and we'll also discuss why groundwater hydrology is very important, and knowing groundwater hydrology, how you could manage it well. With this, let's go to the first lecture of the first week, which is starting from today. And I am an assistant professor with Center for Technology Alternatives for Rural Areas, which is a unique department, a very special department across IIT systems, because Center for Technology Alternatives for Rural Areas works on the ground with rural communities, understands their problems, and tries to seek solutions through technology and development. Before we get into the actual course, I would like to introduce myself and discuss how I got into groundwater hydrology, which is very near and close to me. So I have graduate degrees in physics. I have one master's in physics from Bharathasan University on theoretical physics. Then I have a master's in physics from the US Wesleyan University of Connecticut on experimental physics, and then I did my PhD in hydrology. So I jumped from physics to hydrology, but however, most of the transfer was easy because all the hydrological problems as an experimental guy, I found it coming from physics. So physics is still the fundamental equations, understanding, and the process behind hydrology. So in hydrology, I was trained in surface water hydrology, groundwater hydrology, and also on the nutrient dynamics occurring due to the hydrology, and also on microclimate and climate change because of the changing climate and weather patterns. I also developed some expertise in GIS and remote sensing because when I came back to India after my PhD in University of Missouri in the US, I found that data was limited, and to augment, to add more data, we needed to have different data sources. And remote sensing is one such source where we have multiple proxy data for using in hydrological models. So I learned remote sensing in hydrological models. Then my research profile started as a postdoctoral fellow with ATRI, an NGO in Bangalore. Then I was a researcher focusing on hydrology and remote sensing at International Water Management Institute. And I was placed in offices in India, Sri Lanka, and Nepal, where I did mostly groundwater hydrology research, and then did some studies using remote sensing and GIS. And also I looked at water budgeting, water allocations, and climate change. Then I was promoted as a senior researcher at Nanyang Technological University, which is a key university in Singapore. There I did a lot of flood modeling and flood prediction for the island state of Singapore. A lot of climate change extremes happen, and because of that, island nations are under tremendous risk. So some of my work led into discussing these risk analysis. I'm also a visiting scientist in Darfur, which is with an NGO called Essence of Guru Foundation. And I'm also a visiting professor at University of Oulu, Finland. So currently I'm an assistant professor with Center for Technology Alternatives for Rural Areas in IIT Bombay. And I also lead a data group called Rudra, which means Rural Data Research and Analysis Labs. It is a data lab focused on rural development, where multiple data comes in and we use it to find reasons for the issues and how we could better manage them. So my background has clearly said that I've been across disciplines, but most focusedly in the last 10 to 15 years, I've been working on hydrology and most importantly, groundwater hydrology. I do have experience as a field hydrologist where you go and put in instruments and measure the parameters. And also I have experience where there's no data. I have experience on using GIS and remote sensing. And using the data that I collect from field remote sensing, I was used to drive models. So all these three phases in groundwater hydrology is very important. And in this course, we would be getting an introduction to the complexities of groundwater and the theory behind it so that we can better understand it. With this, I would like to also introduce my team. I'm the lead instructor, Professor Chinasamy, and Mr. Pranad M is a TA. He would be assisting you with all the questions you would have on your homeworks, course curriculum, and also exams. Another TA is Mr. Mohammad Qasim Khan. He would be joining Pranad on helping you maneuver through this course. Both Pranad and Mohammad Qasim Khan are PhD students at IIT Bombay, and they work on hydrological models, drought, flood protection, mitigation, and also data structures. Both of them are currently PhD under me. Then, after the introduction of the personnel, I would like to introduce the books that we'll be using for this course. The most important book I would recommend is Freeze and Cherry's Groundwater book. A lot of government agencies across the world have been using this book, and one of the lead authors has been awarded the Stockholm Water Prize, which is relevant for today, and also it is as big as an award. It is considered as the Nobel Prize for water by many people. So many hydrologists rank this award as very big. So one of the authors have this award. So it is such a detailed book. And even today, even though it was written in 1979, even today it has been widely used. Then because we are discussing about groundwater, there are some surface water and overall hydrological components we need to be very acknowledgeable about. So for that, we have Principles of Hydrology book by Ward and Robinson, where you get the understanding of the basic hydrology. Then we also have Physical Hydrology book by Dingman. And these books, even though they're old, outdated, people might think it's not the case, because the principles and fundamentals of hydrology and groundwater is the same. The physics, the science is the same. Maybe the management, etc., would change. I also have some other books. Introduction to Hydrology by Wiesman et al. 2003. It's a good book. I've taken some notes out of it, and more importantly, Fetter's Applied Hydrogeology. The updated version is 2018. So for India-based, India-focused work, I used extensively the Hydrology Principle Analysis and Design book by Professor Raghunath, 2006. On top of this, there will be a lot of discussions using my field experience for the past 15 years. We'll be discussing literature, which is very new and relevant. Literature published in international scientific journals and academic theses. We would also be looking at government reports and NGO reports. They might not be as cited as papers because they are not in the scientific scholar domain. However, those reports are very, very important because it is a government's report and NGOs work on the ground. Their mandatory is not to publish as a academic journal or an academic work because for them they would like to share their results and reports widely and for that non-scientific journal publications is what they choose. So we'll be looking at a lot of those reports and books for this class. So course introduction and topics will be covered today. So this first lecture is to sensitize everyone on the course need. And this is the hydrogeology map of India from the Central Groundwater Board. In short, it is called the CGWB. It is a Government of India entity who is the key for monitoring groundwater across India. What are the course and topics that will be covered? Most importantly, groundwater hydrology. We will be looking at the overall groundwater hydrology. Importance in India. Why do we need to have such a course for India? So that will be covered. And also introduction to data and modeling. In this course, we would look into how to collect data, how to use collected data from government records and NGOs resources. We would also see how you could understand the need for modeling because modeling itself is an advanced course. You would need a separate lecture for that or a full lecture series for groundwater modeling. What we would be looking at here is an introduction to models, how they work, what do you need to run the models in terms of data, computing power, and also understanding. Then we look at a lot of case studies. Case studies are very important to understand the application of groundwater. So if you look at the way the course has been structured, we give an introduction to groundwater and its components. We discuss about the importance of India, why should we have such a course for India, and then we get into knowing the concerns and issues in India. We get into collection of data, monitoring data, and then modeling. And then we look at case studies from government reports and journals, etc. And my personal field work on how these data and other aspects can clarify us on the problem of groundwater in India. And then we would slowly get into understanding the methods to solve this big problem for India. Before I jump into week one's structure, I would like to also look into the course introduction, which I'll break up the different week structure for the course. So today's lecture would be trying to sensitize on how the course would be staggered and what would be taught in every week so that students who want to attend in the long term can have a vision. Otherwise, I do not want to keep you in the and have later a concept which you may not be interested. And I also want to give surprises on your week contents. So I would discuss in the first lecture, which is today, the overall week structure and what will be covered in these lectures. So in the first week, it will be course introduction. I would go week by week topics, what to expect and what not, so that you can also prepare. For example, I do have some topics on GIS. So you could go and see what is GIS, what is remote sensing, what do you mean by satellite data. So those things you can have self-learning a little bit, but most importantly, it won't be in detail. It will be an introduction. So it will be better to understand this through some homeworks. Introduction to groundwater and why it has to be studied. We'll be going through that aspect today. And let me start with that aspect. So this is the Central Groundwater Board's latest report 2020, giving an image of pre-monsoon level in 2019. So this image shows the groundwater depth or depth to groundwater for the year 2019-2020. And you clearly see that some of the regions are dark red, which means it is very, very scarce, the water. Just for now, let's look at dark red and pink as the concern areas. We'll get into why it's concern, etc. So let's come back to why should we have such a course for Indian context, groundwater course. It is very important because India is first an agrarian nation, which means most of the livelihood for Indian population is still through agriculture or agriculture allied industries like food, cooking, would be the allied industries, transportation, shops, selling groceries, fruits, etc. But farming is the biggest livelihood option in India by population. Okay. And the second part is not all groundwater or surface water is used equally in India for irrigation. So if you take traditionally in the olden times, most of the irrigation was through surface water or rainfall. So not all land is only used for rainfall irrigation in India. There is a lot of use for groundwater. Groundwater access has become very easy in the recent years because there has been a lot of technology and development on pumping and installation of pumps to collect water. So initially the wells were dug by hand. People used to dig a well or tank and etc. for water. But nowadays you can just have a rig or a big machine which is mounted on a truck. It can come through your area, anywhere, any area, village, put down the borehole and then go for 1 lakh or 2 lakh rupees. So the ease to groundwater access has come, and also the pumping cost has come down. The power needed to pump the water has come down through diesel power and also electricity motors. The other thing is, one thing is, yes, agriculture expansion. Indians have also looked at the population at a very, very different angle, right? India is set to overtake China in some years, which means the population is ever increasing. And the weight of supporting the food distribution or feeding this growing population is on farmers, not on technologists, not on any different group of science and technology. It falls on the farmers. The farmers have to feed, correct? So what do? They are forced to increase the productivity, to increase the yield by growing multiple times. So you can have one field, you can grow once and feed people. But if the food is not enough, what do? You grow again, okay? For which water is one of the most important resource for agriculture. So on one side, population is increasing, because of which food demand is increasing. And because of the food demand, your water demand has been increasing because agriculture is driven by water. And all water which is used is not only from rainfall or dams and canals. So that's why groundwater has been used. So that is point number one. In point number two, climate change extremes have kicked in. And in the recent years, you have seen a lot of droughts and floods in India, which means the availability of rainfall is questionable. It is not happening in distributed time so that you can use it widely for 3 months. For example, a crop, if you have monsoon for 3 months, you're fine. But what happens if the rain is concentrated in 1 month or 2 months? you'll get a big flood, and that flood can wash away your crops. More importantly, there's no water for growing the crops or sustaining the crops. At those circumstances, groundwater is used. So groundwater has become the buffer or saving tool during climate change extremes, both floods and droughts. So if there's no rainfall for 1 year or 2 years because of a big drought, then groundwater is being used to augment and grow the crops. So groundwater is at tremendous pressure, especially in India, because of these two factors: population, food, and then climate change extremes, etc. And because of that, India is the world's leader in extraction of groundwater. CGWB approximately estimates it to be 245 kilometer cube or billion cubic meter, which is almost higher than the total groundwater extracted by US and China. So I say almost because China's numbers estimates is not very clear for everyone, but your US, and if you know the crops, irrigation patterns, etc. So the estimates now tell us that even if you take groundwater used by US and groundwater used by China, which is the second and third ranking highest extractors of groundwater, India's groundwater use is much, much higher. We don't have as big of an area like US or China. We don't get as much rainfall as US and China, but we are putting so much pressure on groundwater. So by these factors, I hope you understand that understanding groundwater is very, very important for India. Preserving groundwater is very important for India, and managing groundwater in a scientific way is important for India. And for this course has been designed to introduce the concepts, to sensitize you on groundwater hydrology and the methods of management practices. Let's look at the course week by week topics. The first week, we would be looking at the introduction to groundwater and also why groundwater is important. In week 2, we would discuss some international use of groundwater, like in different countries, how it has been used. And we would focus more on groundwater use in India. So we'll have understandings from other regions. What do they use it for? How do they grow the crops, etc. And then we will focus on groundwater use in India. Week 3, we will discuss the physics and hydrology of groundwater. As I said, physics drives these systems. And it is very, very important to understand why water would get into the ground, why water moves across the ground as groundwater, and also where does the water go and by what processes. What is the pressure? How does it flow from one point to another point? All these different aspects we will be discussing. In week 4, we will be looking at groundwater governing equations. As I said, once the physics is established, you would have a set of equations to model or understand the groundwater. So there are groundwater governing equations which should be discussed in week 4. And there are two major types of aquifers, unconfined and confined. In the week 4, we would look into the unconfined aquifers. The type of aquifers would be discussed earlier for your benefit in week 3. Moving on, in week 5, as I said, we would be looking at groundwater governing equations for the confined aquifer, which is the part 2. So both aquifers are very important. To give you a small peek, so groundwater 1 equations would be on unconfined, which is your shallow wells, where farmers can dig a well and excavate land a little bit to have a big well, and then they take water out. Whereas your week 5 would be on the deeper tube wells, which more urban houses uses. And then you have farmers pumping water from deep, deep bore wells. So those equations are different. Both are separate and they'll be different, and we'll be looking at what are the equations that govern and how they govern the system. Week 6 is important. Once we understand the differences between the two systems, we would also understand the need for recharging and discharging these two units differently. So in combination, we would be looking at groundwater recharge and discharge. Once we understand the concept of groundwater recharge and discharge, we will get into types of groundwater wells and pumping sources. So the types are very important to understand the groundwater use. Use is just using it, abuse is overusing it. And groundwater conservation. So for that, it is very important to understand the structure of groundwater wells, because only through wells you are accessing the groundwater, and also understand the pumping sources. So we'll distribute our focus on not only wells, but also understanding the types of pumping sources, water being used differently through the groundwater wells. All those things we would be discussing in week 7. In week 8, with all these understandings from the previous weeks, we would construct a conceptual model for groundwater. The conceptual model is something that can explain the processes visually. Okay, so if you have equations, if you have the types, etc., on paper or on a report, it is not as clearly driving the message, but an image which captures all these aspects can be used as a conceptual model, and those models are the base for groundwater models, where you need to first create the conceptual model and groundwater model is being run. It is similar to solving any physics problem. What does your professor or teacher ask you to do? First, draw the problem, right? If you have a physics equation about motion or velocity, finding the acceleration, they'll ask you to draw and then put the values and then get it. So similarly, a concept can be put in as a conceptual model for groundwater. Moving on, in week 9, we'll be looking at groundwater data in India. What are the different data resources that we can use? We'll be looking at management of groundwater quantity and quality in India. So this week is very specific about how can you manage the groundwater, both quantity wise and better quality wise for India. In week 11, we'll be introducing some groundwater modeling and groundwater software packages in this lecture. It won't be a full-fledged in-depth exercise because both of these topics would itself take a course. So in the week 11, we'll be only introducing you to what is the groundwater modeling concept, how do they model it with a computer simulation, and what are the different groundwater software packages, both open source and paid per use models. And then we wrap everything up at week 12 by discussing some case studies in India, very important case studies which have been considerably used and widely discussed in India, so that you get an understanding of why we need to study groundwater and how can we use groundwater solving these problems. With this, I'll see you in the next lecture. Thank you.